Okay, students, we're going to go ahead and do a few of these problems here. First half, what's nice about it is they've already graphed the lines for you. To save you time, you're just checking if there's one solution, no solution, or infinitely many. So if I look right here, number one, we'll do number one. There's that line right there. In number two, there's this line, or still number one, but equation two. There's that line right there. And when you're solving a system of equations, you're trying to find where they intersect. So notice those two lines intersect at that point. What is that point? -2, -1. Okay. Because it says if it has one solution, as it says right here, name it. Okay. So that's what you're doing for all those right there. Let's go ahead and move down. If there's no solutions, that means they're parallel and they do not intersect. And if there's infinitely many solutions, they're not only parallel, but they're the exact same line. One is just a multiple of the other, for example. All right. Now, instead of giving the line to you as it did up above, you actually have to graph it yourself and then do the same thing. Okay. So let's go ahead and let's do number 9. So this one, nice and easy because it's already in slope-intercept form. So the slope is 2, which is 2 over 1, up to right 1. Y-intercept 0, -3. So you start at 0, -3, go up to right 1, up to right 1, and there's that line. Okay, I can move that slightly right like that. Okay, and then put arrows on the ends. And to solve this one for y, I subtract the 6 across and then divide each term by 2. So you get y equals 2x minus 3. Well, look at y equals 2x minus 3. Y equals 2x minus 3. They're the exact same line. So therefore, how many solutions are there? Infinite. Okay, and as a side note, there's a difference between all real and infinite. Infinite is how many solutions there are. If they want the answer to be what are the solutions, the solutions are all real numbers. Do not confuse the two. One asks how many, one asks what they are. Okay, next page. Elimination method. We're starting with the basic ones. Notice there's elimination using adding or subtracting. That means in all of these, I could just add straight down and eliminate one of them, or subtract straight down and eliminate one of them. Okay, that's the most basic you can get. You'll notice almost all these equations, they're basically in standard form. The only difference is in true standard form, the a, which the, remember, standard form is ax plus by equals c. They all look like that, okay, on all of these here, on this whole side here. But in true standard form, in a, b, and c are integers, which they all are, okay? But in true standard form, there's one more condition where a has to be greater than 0. Well, if you're solving systems by basic elimination method, put them in standard form, a does not have to be greater than 0. So here's an example where a is less than 0, a is -1 there. So that condition itself doesn't matter when you're solving systems by elimination. You really just want to make sure the first two are in place. And technically, even the second one doesn't have to be true. They don't have to all be integers, but then you're going to deal with fractions. So it'd be smarter to get rid of the fractions by multiplying the whole equation by the common denominator and change it into all integers, and then go ahead and apply the elimination method. Okay, so truly what you have to have for the elimination method is 2 equations in that form to use the elimination method in this way right here, okay, which is the standard way that most teach it. Okay, so let's just go ahead and do number 2 since we started that. Notice, if I add straight down, will I eliminate either the x's or the y's? Yes, -1 plus 1 is 0. The x's are gone. I get y plus y is 2y, 1y plus 1y, and 11 plus 1 is 12. I divide by 2 and I get y equals 6. Okay? I'm not done, because remember, don't forget, when I solve a system of equations, I'm finding the point of intersection. So I need an x and a y coordinate. So now I have the y coordinate, 6, and now I go ahead and plug it into either of the equations to solve for y. So I'm just going to plug it into this right here. 6 plus what is 11? 5. So x is 5. So the point is 5 comma 6. Write it as a point. If you're doing a placement test, for example, or standardized test, it's going to be written as a point like that. So get used to writing it as a point. Okay. So you can do that on every single one of these problems. Okay. Even on number 15 here, if you look here with fractions, if I add straight down, these x's eliminate right there. And I would add straight down here. Negative 4/3 plus negative 2/3 is negative 6/3. And of course, negative 6/3 reduces to negative 2. So negative 2y equals 2. Y equals negative 1. And then plug that back in, solve for x. Okay, that will end this video.